The best way to test the two life cycle assessment methodologies was to develop a case study and discover barriers during the process. In August of 1992, Hurricane Andrew, a Category 4 storm, made landfall in South Florida. At the time, Andrew was the strongest recorded hurricane to strike the United States. Andrew was studied because I had damage data in both dollars and damage counts, values I would need in order to complete EIO and process-based studies. I'll start first with the EIO LCA. Hurricane Andrew resulted in over $22 billion in losses, with residential structure damage representing half the total. The dataset had losses broken into 19 categories that were matched with an available EIO sector. Some damage categories matched well with EIO sectors, like residential structures and agricultural equipment. For other sectors, the match wasn't ideal, like residential contents, but it provided a reasonable assumption that could be improved in later studies. Using the Carnegie Mellon resource, the EIO method was applied to each sector. The overall emissions to rebuild came out to just over 14 million metric tons of CO2 equivalent. This number is the amount of emissions used to replace buildings and contents damaged by the disaster. But to more accurately measure the real impact of the hurricane, it must be considered that at the time of the event, there were structures that were near the end of their life. Dilapidated structures that may have been demolished and replaced regardless of the event should not be counted the same as a structure that was just constructed. To account for this, the overall emissions were divided by 2 to assume that all structures and contents destroyed by the hurricane were halfway through their design life. When divided by 2, the emissions caused by the event are just over 7 million metric tons, which is equivalent to burning 786 million gallons of gasoline. Next, the same calculation was performed, but this time applying the process-based method to residential losses. Over 28,000 housing units were destroyed in the hurricane, and another 107 were damaged. To determine the emissions using the process-based method, replacement percentages had to be assigned to each damage state. FEMA defines 4 damage states: destroyed, major, minor, and affected. Destroyed is defined as a total loss. Major damage is defined as more than 50% damage to the structure. Minor damage is defined as less than 50% of damage to the structure and uninhabitable. The last category, affected, lists structures that sustain damage but are habitable during repair. In the table on the right, I show my assumed reduction factors based on the FEMA designations. Also included are the average square footages of different housing types obtained from U.S. Census data. Lastly is the emissions per meter squared ratio for residential structures. Multiplying these values across each row and then dividing by 2, we get 1.92 million tons of emissions to reconstruct all housing damage. Comparing the residential sector emissions between the EIO and PB methods, you'll see that the EIO method is roughly 80% larger than the PB method for residential buildings. The results are on the same order of magnitude, but they certainly are a ways off from one another. There are 2 reasons I've found for this difference. The first comes from a deeper dive into the literature. Others have tested the difference between methodologies and found that the EIO LCA is roughly 90% greater than the PB. The reason for this is explained largely by the bounds that each assessment type works within. I explain this best with a graphic. When the PB method is completed, researchers attempt to trace all the components and processes back to the mining of each resource. This is close to impossible for components that have lots of pieces and lots of different materials, like a house. The EIO method does a better job of measuring everything upstream because it is using data that is sector-wide. The second reason for the difference can be attributed to errors in the primary data used. As is common in disasters, there is a quick rush to report the total number of damaged and destroyed units, but final numbers are rarely communicated. In the case of Hurricane Andrew, the final price tag was $22 billion, and the initial inventory counted 135,000 damaged or destroyed housing units. But there were over 280,000 different claims paid following Hurricane Andrew, over twice the number included in the assessment. It's likely that a number of these were in the minor and affected categories, but even if that's the case, it closes the gap between the 2 methods. There's definitely a lot to be done to try and converge the 2 methods, but at play are issues of reliable data for both LCA methodologies, as well as better reporting of disaster losses. With an understanding of the LCA process, they were applied to study the emissions of future hazard losses.